So you can already interpret displacement time graphs. Now you really want to interpret velocity time graphs and see the relationship between the displacement time graph and the velocity time graph. So on my left here is a displacement time graph, and on my right is a velocity time graph. Now you shouldn't have trouble interpreting this. Some object started in front of the origin and stayed still. Now if that's the case, its velocity is 0. Alright, so this graph and this graph, they're related. This is the velocity graph, this is the displacement graph. Let's do a bunch of these. Starts a little bit in front of the origin, which doesn't matter in terms of a velocity graph. The place you begin does not matter. And moves at a constant speed. We can see it's moving at a constant speed because it's a straight line. On your velocity time graph, it's going to be pretty boring. Constant speed. Maybe it's like 5 meters per second or something like that. Constant speed over time. Okay. This one here, it's moving at a constant speed, but the velocity is negative because it's moving backwards towards the origin. So here on my velocity time graph, I'm going to have a negative velocity, maybe -5 this time, meters per second. So just be very aware, moving downwards. This isn't a speed time graph, this is a velocity time graph, and velocity can be positive or negative. Okay, this one's an interesting one. Starts at the origin, doesn't make any progress at all. So for point A, you can see our velocity is 0 for that first section. Then our velocity abruptly moves up. We jump straight to moving at a certain speed, maybe like whatever that gradient is. So maybe we're moving at 4 meters per second, and then we abruptly slow down, 2 meters per second. Worth noting that this is fairly, I guess, unrealistic in a sense. You need some speed up or slow down time. Things don't just jump from one speed to another like that. Alright, this one is the sort of thing I'm talking about. If you look at this, here's my displacement time. Displacement time. So, over time, in the beginning, I don't move very far. It's almost flat. And then I move a little further, and then I move a little further. So from time 0 to time 1, from time 0 to time 1, I barely move at all. From time 1 to time 2, I move a great deal. From time 2 to time 3, much more. Time 3 to time 4, more again. So I'm accelerating. And due to the nature of this curve, I'm accelerating at a constant rate. So my velocity starts slow, then my velocity is greater, then my velocity is greater, then my velocity is greater, then my velocity is greater again. So 1 meter per second, then 2 meters per second, then 3 meters per second, then 4 meters per second. I'm getting faster and faster and faster as I go. Alright, here's the opposite kind of curve. I start off by going really fast. In the first second, I cover heaps of ground. In the second second, less ground. Third second. In the fourth to the fifth second, my displacement's barely increasing at all. This is a a decreasing velocity. So I might have had a velocity of 5 meters per second, then 4 meters per second, then 3 meters, until eventually I've got a velocity of 0 meters per second. Alright, interesting, we've got a parabola here, or at least it looks like a parabola. So, displacement's quite quick to begin with. Displacement slows down. Displacement is starting to speed up again, but it's negative now. I'm going back towards the origin. So, if I line up my points, this turning point here lines up with this spot here. So, start off by going really fast velocity, then less velocity, less velocity, less velocity, zero velocity, that's when I'm turning around, and then a little bit negative, a bit more negative, a bit more negative, very negative. That's when I get down to here. Alright. That's velocity time graphs. You've just had a sneak peek that we've obviously got one more to go.